My name is Mason Kuhn. I teach 4th grade at Shell Rock Elementary in the Waverly Shell Rock School District. One of the main goals of the SWH PLC this year was to have a group of teachers look at how we teach science. And even though we were looking at the specifics of the SWH approach, the much more broader context of thinking how the transmission of knowledge is not something that you can physically give another student. Knowledge is not something that you can just hand and say, here it is. Education and knowledge is an activity, and the students need to be involved in that activity. It cannot be completely teacher-led, and the questions and the activities cannot be completely teacher-led.
We're going to get started out with an activity, and what I want you guys to do is I want you to write down every thought that comes in your head after you watch this.
One way the SWH is different from traditional science approaches is we do an initial activity to get the kids' ideas flowing. We're trying to get them to come up with some big questions and generate a big idea, which will be the overarching goal of the unit. And we do that by having an activity like just giving them some materials to play with, or having them watch a video, or giving them a specific task like building a rocket and then having them shoot that rocket and ask, how did your design help that rocket move? Or play with some toys and say, how did this toy truck move the way it did? What caused it to move the way it did? After the kids have made some observations, the next thing we like to do is have them have a discussion with each other and bring those questions up. And we never tell a kid that there's a bad question or a wrong question. We always have them put it out there, and we just kind of discuss if it's going to fit into the unit that we're working on. And we usually put those questions up in a public display, and we decide if they're something that we can test further at school or if it's something that we can do some research on later on. But those questions are always student-led, not teacher-led. After we find a testable question, the next thing we do is we have the students come up with an activity and actually plan out the activity, including identifying variables, identifying independent variables and dependent variables, coming up with methods to collect data, and then later on analyzing that data. And again, this is all student-led. The teacher is there as a facilitator, and their teacher's there to guide them if there's any place that we need to step in and offer some guidance. But typically, the kids figure it out themselves, and they can plan some really amazing creative ideas themselves. After the students collect data, after the experiment is over, we go through a number of different negotiation phases where, again, the students are given the question, why do you think you received the data that you received? Why do you think the rocket moved the certain way it did? Why do you think this vehicle moved the way it did? It's not us as teachers telling them this is why the rocket moved that way. It's them first thinking about it and trying to figure it out themselves, and then later on, if we need to interject with some writings or some information from scientists that have published things, we can do that, or we can get it straight out of the textbook, or we can get it from our own knowledge of the subject. But initially, again, it's always the kids having questions themselves and trying to negotiate their understanding.
Going to be doing. We want it's under the physical science, and forces are related to an object's motion, and a subset of that is change in motion is caused by forces. So that's what's kind of driving our big idea and our activities.
The final stage is the write to learn stage, where students write non-traditional texts to an audience that is not the teacher. We found that when kids write solely to the teacher, a lot of times they use big vocabulary that doesn't really make sense to them, but they're just trying to satisfy what they think the teacher wants to hear. And typically they'll maybe write in a way or write about something that they don't completely understand it. We like to have them write to a younger audience and translate the knowledge in a way that will make sense to the younger audience. And we find when that happens, the students a lot of time ask clarifying questions, not because they think I have to get this information correct for the teacher, but they want to make sure it's right for that audience, for those younger students that they are writing to. Using this approach 4 years ago, and it probably took at least 1.5 years to even start to get comfortable with it. It's definitely not something that you can read a book about it or try it out 1 or 2 times and be an expert at it. 4 years into using the SWH approach, I'm still learning something new every single year from my colleagues, from my students. It's a process. It's not a bag of tricks where you just follow a script and do step 1, then step 2, then step 3. It's a completely non-linear process, and it's something that if you really try it and you really give it a go, I think it's incredibly valuable. But it can be frustrating at the beginning because you're giving up that perception of control that you have in the classroom, and you really have to sit back and let the students run the show, which is not comfortable at first. But after doing it for a few years, I couldn't teach any other way.
I like science because we get to do the kids get to do what we want to do, and the grown-ups just don't make the experiments, the kids do, and we make the big idea.
I like doing science the SWH way because we get to come up with our own big idea, make books on Keynote and the computer, and we just get to do a lot of negotiating, which is really fun because we each get to have data to back it up.
After our experiment, we get to write books and PowerPoints about what we learned and facts about it, and then we show them to older and younger kids.
I like the science that we do here is because we get to pick like the experiments that we do, and we're not doing them over and over again, and we get to pick like our own interest in science.
I like science because you get to do experiments and you get to see how it's actually worked instead of just reading books and not knowing how it works and stuff.